Hello and welcome to our lecture series. Before we dive into the individual topics, let's start with the introduction to data science and artificial intelligence. So data science and AI continue to shape our world, and I've assembled here a few examples where AI will somehow revolutionize our fields. For example, in factories and automated assemblies, but also in warehouse and shipping. We're all becoming aware of autonomous vehicles like self-driving cars, but this can also be used for deliveries, for example. The first examples start to emerge also in social care with like robot nurses. They will not anytime soon replace all the care, but they can help certainly, for example, deliver food. We're also all aware of drones. Sometimes they're just toys, but we can also use them for farming to monitor agriculture or to monitor the progress of construction site or even people. And more in healthcare, new applications of data science and artificial intelligence start to emerge. Another example is indeed education. For example, this video was entirely produced by an AI.
Hey, welcome to our course in Python and data science.
Of course, this is just a short demo version, but in principle I could type in all the text or even use ChatGPT to generate sometimes more, sometimes less meaningful text. But you can already see from this simple example here that it starts to become very useful also as a teaching aid. The first university textbooks have also been written entirely by AI, as this press conference from Springer illustrates. So this bright new world, where does it lead us? Well, on the other hand, it's maybe not quite as bright. Amazon, for example, will likely replace in these warehouses a lot of its workers. If you do use AI in businesses, you'll probably have some processes, and if you digitize them with an AI, you will have likely the same processes, so you need to take care that you innovate appropriately. There's also the world's first robot citizen that has been granted citizen status. So that opens another whole avenue of thought of how do we want to live with AI in the future. But there are also applications that are maybe a bit astonishing, maybe even frightening, like for example mind reading. There's an algorithm where you can put yourself into an MRT machine and it then can reconstruct more or less what you're thinking. It's not quite accurate yet, but it starts to become the topic of a science fiction novel maybe. There's also this example here from MIT where they used AI to reconstruct what a likely face looked like from the voice. And even AI is used in the judicial system and can help send you to prison. So these are all applications where AI is already being used, but we have to think carefully where we want to go as a society. Look at these examples here. We're all familiar since the pandemic with video conferencing software and virtual background removals. And you can see here on the left that the person with a darker skin color is not really recognized by AI. There are also autonomous weapons system and also in the image generation AIs that are currently available to us. If you choose your words, for example, like CEO, you're more likely to get a white man instead of a woman. Or if you give it a prompt like caretaker, you're much more likely to get a woman. So there are lots of problems and biases that we need to be aware of. Of course, each new technology has its advantages and disadvantages and can be used in several ways. One of this is drug discovery, and there was a recent paper which is quite interesting in the sense that it sheds light on a very specific problem in drug discovery. Of course, generally we want to assume that we use new medicine for benevolent cases. So AI can speed up the drug discovery for diseases, and for example AlphaFold has made spectacular successes in predicting the 3 protein structure, which is then used to develop, for example, new medicines. The AI can also predict the toxicity of certain substances, so in the development of new medicines we can avoid them. However, we can also turn this around. The AI can predict the toxicity of a substance. And in a recent study, researchers have used this, and they found that very quickly, not only did the AI discover the known poisons, but also come up with a new one. So let's go back and take one step back and discuss what is actually machine learning, and it's been around for quite a long time. And to quote one of the fathers of machine learning, we can say machine learning is the art of programming of a digital computer to behave in a way which, that if done by humans or animals, we would describe as involving the process of learning. And what is then data science? There is no single definition to it, but generally we can view data science at the intersection of all relevant domains. We have modeling, that is typically done in statistics and probabilities. We have algorithms and data infrastructure, so we need to build all the computer networks and everything that we can then use to store and process data. But we also need to focus on building software and choosing and developing the right algorithms. And crucially, in data science, we need expert domain knowledge. We need to understand what we want to analyze, what the results mean, what the data are like, and what the data mean, what kind of problems we have. So this is depicted in this Venn diagram here. If we take a rather simple approach and say we have computer science up here, statistics and modeling up there, and domain knowledge down there. So we have maybe on the intersection between computer science, algorithms and data structure, and statistics and modeling, the machine learning part. Statistics and modeling and domain knowledge, this is typically the classical, traditional research that we've been doing. The intersection of computer science and data infrastructure with domain knowledge is likely the result of traditional software development. But if you want to do data science, we need to become experts in all three of these areas. Now in reality, not a single person can master all of this, so data science is inherently a team game. What is AI then? That's also not quite as easy to define. We all maybe remember Hal from the movie, but in current systems we can discuss this in the terms of weak or narrow AI and strong or general AI. So what do we mean by weak or narrow AI? It's not weak as such. It means that this system is able to solve a particular task same or better as humans do. For example, it can play Go, or it can drive cars, or it can predict the structure of materials, or it can order new goods for you. So all of these AIs may be better than a single human at these tasks, but you couldn't, for example, ask a Go AI to drive a car. The strong and general AI is then something like you would expect from a system when we talk about in general AI. It's likely to achieve or surpass general human intelligence. And it's something like if we were to encounter such an AI, we might be able to converse with it about different topics, or it may do many tasks. However, the jury is still out when we will develop such a general AI, and also it may not be interested in us humans at all. Same in really, like we're not really that much interested in ants, for example, or other animals unless we study them. We may find ourselves in this situation at some point in the future. So what do we need to learn when we use machine learning, artificial intelligence? Let's take a very, very simple picture from an academic point of view. We have data, we put it into the machine learning algorithm, and out comes a publication. That is very simplistic. Especially if you work in a commercial environment, you really are not done with producing a single result. You need to run a business, or you control a production plant or something like this. So you pour in data into your machine learning AI system, and then you get some predictions, and these are in general probabilities. Now you need to do some impact assessment and determine how to use the output of the machine learning algorithm to optimize, for example, the control of your production plant. So any machine learning algorithm, at least outside the study or outside an academic publication, is only useful if you can connect it to decisions and actions. So we'll span the whole region a bit, and in this course we only focus on parts of it. So we need to focus on the data, we need to focus on the machine learning and AI systems, we need to focus on predictions and their assessment and how this leads to actions. In machine learning and AI, we need to learn what and how we do this. So we need to have some sort of understanding of programming. We also need to have some understanding of statistics and causal relationships. And of course, we need to know the machine learning and deep learning algorithms. There's a whole load, which we'll probably not cover in any detail. In particular, the data infrastructure. This is equally important because without data, we can't do machine learning. So if you want to then progress, you need to learn a lot about databases, network setups, storage systems, and also you need to know about the domain you want to apply machine learning or AI in, because you need to assess if the data you want to give the machine learning algorithm is of sufficient quality. But before all of this comes the evaluation of a use case. Especially since all our time is limited, either in a research project you need to decide what to do, you yourself or together, for example, with your supervisor, but also in a business, you need to decide which area to invest in. So you need to assess what you actually want to do and why you want to do this. And then you want to determine if it's actually feasible and how much effort this will be, because that will determine your project scope and cost. And if you do it in a commercial environment, you also need to determine if this project has any commercial business value. Because a nice project might be very interesting, but if the gain is incremental, your time is better be spent elsewhere. But back to the day job of a data scientist, what are you actually doing? And this is maybe a bit frustrating, because according to a recent survey, most of the time you will actually not be spending building data science machine learning models. You will be spending time with the data, processing data, understanding data, and in particular making sure that the data is of sufficient quality. Data quality is a key topic in data science. Of course, here in our courses, but also in competitions like Kaggle and others, this step has already been done. The data are already cleaned, and outliers and so on have been removed unless this is part of the exercise, and you only get given relevant data, which is typically also fully labeled. And in all these competitions, you also get given a specific assessment metric. In real life, someone needs to do all of this, and this is why we spend so much time as a data scientist to think about the data, the infrastructure, data quality, assessment metrics, and so on, and relatively little time on actually building machine learning algorithms. Now let's come to some notable successes, especially in the field of material science. There are many new applications of data science and AI in this field. For example, the prediction of material properties from the crystal structure, the behavior of materials with respect to defects. There's a large research areas in materials discovery and design, and this not only refers to, for example, metals and others, but also to polymers. On the theory side, machine learning starts to enter the game as well and complement traditional computational method. For example, machine learning methods have proven to be an invaluable tool. Similarly, experimental methods are now more and more augmented by using artificial intelligence, and this opens up avenues to pursue further research that was not possible when AI and data science machine learning models haven't been part of the process. So data becomes really pivotal to all our domains. Machine learning and AI will continue to transform and disrupt entire fields, including yours.